Okay, good afternoon everyone. My name's Karl. I am the streetlighting service manager for East Riding of Yorkshire Council, and I'm also the project manager for our Live Labs 2 project, looking at how we decarbonise street lighting. So what I'm going to do is I'm going to play you a video for about 10-15 minutes, and then I'm open for questions.
So the Live Labs project is to try and decarbonise the road network assets. The East Riding's particular bit is focusing on the street lighting element. We managed to gain £3.3 million worth of funding to help with that project, and it's been rolled out over this last year. It's really important to work with local authorities so we can share that data, gain more data from their local authorities, and then we can add that to our project to try and demonstrate that what the officers are trying to do is beneficial to the UK and ultimately try and get our vision of a net zero economy.
So Live Labs 2 is a Department of Transport funded UK-wide project looking at decarbonising the highway. So understanding the carbon footprint of highways assets, highways operations and their end of life, and looking at new and innovative ways on how we can change that, how we can do things differently, and how can we can reduce the overall carbon footprint. Our project looking at street lighting, bollards, traffic signs, white lines and illuminated road studs, looking at how we can change perceived design practice around those things but still give the driver the visual indications they need to be able to navigate the road in a safe manner. This project, whilst it's about carbon reduction, our project specifically is about driver safety. Okay, and we need to evidence that the changes that we make by switching from street lighting to this new layout is as safe, or if not safer, than it was before. So what we've employed is a world first CCTV system at various points across the two test routes, which are the A164 and the A1079. Okay, so we're in our CCTV control room for East Riding of Yorkshire Council, where we monitor CCTV from across the county. But this is also the home of our cutting edge artificial intelligence system that we've deployed for our Live Labs project. The system is a world first. It's never been utilised before anywhere. It's been developed specifically for our project, and we're using thermal imaging cameras to monitor driver behaviour. So counting different types of vehicles, the number of HGVs, cars, etc., pedestrians, cyclists, and looking at things such as speed, braking, reaction times, lane positioning. And we're doing this using the thermal imaging so that we can monitor how drivers behave on our test routes previous or under the existing conditions, so with street lights on and through the daytime and such. But then when we move to a situation where we've replaced the street lighting with the new equipment, then we can also monitor and get the same data under those conditions of total darkness. So for the East Riding public and hopefully road users across the country, there'll be two key things that come out of this project. One is roads that have a much lower carbon footprint. But overall, our primary aim around this is to make the roads as safe as they were already, but hopefully safer.
The second year of the project has seen us delving into the mystical world of carbon assessment. Early in the year, we finalised our carbon baselining for our test beds, which threw up some interesting context and results, with the business as usual lit assets being responsible for over 940 tonnes of CO2 equivalent over a whole life period of 40 years. And over the last 12 months, we've been working with Leeds University to develop a tool specifically aimed at local authorities and the unique challenges that we face. Our carbon and financial decision support tool functions at detailed designer and scheme level, but can also function at strategic decision maker level. It allows the user to input the proposed street lighting and lit asset scheme along with an alternative scheme based on our Live Labs methodology, and produces a carbon and financial appraisal between the two. This can allow for detailed design appraisal pre-construction or on a wider existing asset level around which a business case can be built. The tool works on the key assumption that we're capturing beyond the depot gate activities, as did our baseline. However, crucially and different to our baseline, it takes into account a very important factor when dealing with street lighting and other electrically based systems, and that is grid decarbonisation. Our electricity production is scheduled to be net zero by 2050, which is crucial when dealing with electrically based assets whose lifespan goes up to and beyond this date. Our current baseline shows that 35% of the carbon footprint of an A-road streetlight is made up of materials and maintenance in 2024. In 2051, with grid decarbonisation, this will be 100%, and whilst the overall carbon impact will reduce, there will be still significant amounts made up from the materials. Our tool factors that in, allowing the user to understand at what stage to replace assets to have the highest carbon impact. We've made huge strides forward since you joined us last year, and after spending the first year of the project researching possible alternatives to traditional street lighting for complex road layouts such as junctions, roundabouts and crossroads, in year 2 we've moved into the delivery phase of the test beds. Our initial review of the test sites highlighted that we had 2 distinct typologies, those with pedestrian walkway alongside and those without. Carriageway designs follow our standard design layout for all sites. However, for pedestrians, we're trialling new pedestrian-only lighting, which we will discuss further later in this video. Carriageway designs incorporate a range of alternative equipment, all designed to provide highly visible, intuitive and low-carbon alternatives to street lighting, and they work as a complementary suite of interventions with no single item standing apart from the others. And as part of the research process, we look carefully into the properties of each of the alternative elements. The solar-powered illuminated road studs, which give lane delineation for up to 900 metres beyond the vehicle, the retro-reflectivity of the line markings, and the retro-reflectivity of various sign materials available on the market today. These designs, though, are not all straight replications of the existing assets on site with new assets. The lining has been replaced on a like-for-like basis with a selection of products ranging from 200 millicandela retro-reflectivity up to 400 millicandela retro-reflectivity. The illuminated road studs have been placed at locations as per regulation and colours as dictated by TSRGD, with one addition. We've chosen to delineate the islands of roundabouts with amber road studs with alternating orientations between perpendicular to the curb line to assist circulating traffic and at 90 degrees to the curb line for oncoming visibility. But it's in the sign materials where we see significant change. When researching the properties of sign materials, 2 things became very apparent. The standard Class 2 material has significant loss of retro-reflectivity at close distance, to the point where, for an HGV driver, the sign would become invisible. Also, the negative effect of water on the material. Water on a sign face essentially reduces its retro-reflectivity to almost zero, no matter what distance it's being viewed at. However, we also found that Class 3 materials, motorway grade materials, maintain a significant level of visibility at close distance regardless of the vehicle and the driver position in that vehicle. And because of this, our design now incorporates Class 3 materials on all verge-mounted signs for improved driver visibility, but retains Class 2 materials on signs in direct line of vehicle headlights, such as chevrons on roundabout islands, to ensure that we do not glare drivers with their own headlights. We've also incorporated a water repellent overlay to the signs to reduce the impact of wet weather on the sign visibility. And we've also explored the effects of the removal of lighting on all users' general spatial and distance awareness. We've added solar-powered vehicle-activated signs on all high-speed approaches to complex sections, calibrated to the stopping distance at 40 miles per hour for additional driver awareness. We've also installed additional distance indicators to signs to give drivers greater awareness of an oncoming complex area. In total, we've installed over 5,000 illuminated road studs of various colours, over 80 kilometres of new lining, and over 140 square metres of new signage. Our first phase of test sites are now complete, and we're ready for de-illumination of all test sites without pedestrian lighting, which is scheduled for the first week of April. But not all the work is taking place in the East Riding. We also have test beds throughout the UK, all following the same approach as East Riding and all monitored by our AI system in order to show that any changes in driver behaviour we see are not a geographic phenomenon. Across the test beds we have currently confirmed in Aberdeenshire, Hull, Lancashire, Derbyshire and Oxfordshire, we have a range of complex areas being trialled, replicating those being undertaken in the East Riding. These test beds have followed the exact same principles as the primary test sites: risk assessment and audit, collision history review and design approval. 2 of these test sites also include a pedestrian-only lighting test bed currently under design. These national test beds are in the final stages of approval, with some beginning construction imminently and anticipated completion in the late spring, with more coming online in the summer, and we are supporting these partners to navigate both the political and communications landscape based on our own experiences. We're also working with authorities outside of our direct Live Lab cohort, such as Staffordshire, to support Live Labs based work in their areas, and working with Westminster Council on areas of urban decarbonisation. The risk assessment process has been fundamental for ensuring we choose the most appropriate test sites. Supported by our AI system and the granular data we receive, we can ensure that we are making the correct adjustments and have made the appropriate improvements for the obvious safety concerns that are generated by the removal of street lighting from complex road layouts. Key to this process has been the 10-year collision history review undertaken for each test site. This assessment has drawn out some interesting findings, such as 80% of collisions occur during daylight hours, or that the most common form of recorded collision being a direct result of driver error and lack of awareness of other road users, not poor engineering. The risk assessments and safety audits with the provision of lighting as a last resort have ensured that we take all additional precautions necessary to give the road user the advanced awareness of the location approaching to avoid last-minute surprises. General design practice and current British standards incorporate footway lighting as part of general road lighting design. For specific footway-only lighting, such as active travel routes, our current standards indicate that they should be lit to road lighting levels. But is this appropriate for pedestrians to make a threat assessment at distance while still being able to see the surface that they're walking on? In short, our standards for pedestrian-only lighting are poor compared to other parts of the world, where they are specifically set out as a distinct environment with distinct needs. So we posed 8 different manufacturers the problem of designing a lighting scheme specifically for pedestrians that only lights the footway with no spill into the carriageway, to provide lighting for the users that actually need it, along with making it as carbon minimal as possible. These designs have been checked by leading street lighting professionals and are now in the process of being installed. We're installing a range of schemes varying from the use of 1 metre illuminated bollards to sites using wooden columns, recycled aluminium columns, and column heights dropping from 10 and 12 metres down to 3 and 4 metres. We will monitor the usage of these sites using our AI system and undertake on-site surveying to allow the users to show and tell us what is good lighting. There are also possible secondary benefits to either the complete removal of street lighting or moving from general lighting to more focused pedestrian lighting, such as possible positive impacts on local biodiversity. As part of the project, we are placing audio sensors at key points on a test site of total de-illumination, a site of pedestrian-only lighting, and a control site maintaining standard lighting. Using the audio sensors, we are monitoring both bird and bat species with a focus on the levels and timings of activity, along with the different species present, particularly nocturnal species. We're also using AI to monitor moth species and numbers across the sites, and will maintain this monitoring for the next 3 to 5 years to show trends over time. We're also engaging with local communities to host activities such as bat walks, mammal counts, and butterfly counts to raise positive project awareness in the community and bring in additional biodiversity data.
Okay, thank you ever so much.